Welcome.
To the joy of coding.
Hello, and welcome to episode 99 of The Joy of Coding. My name's Mike Conley. We got a great episode lined up for you today. It's, sorry, I've got food on my fingers. I guess I was eating sloppily at lunch. I apologize. Hi. We're going to be hacking on Firefox today. We're going to be writing some performance tests. We're going to try and make sure that Firefox stays zippy and snappy. Welcome. I'm so glad you could be here to join us. So what do I need to say? Nothing. Let's get started. So here's my screen. And today's agenda this is May 3rd, 2017. A reminder, no plan survives breakfast. Again, I gotta pull food out of my teeth. So first, I need to make sure, is everything working? Yeah, you can hear me. Yes, and the sounds work. Yep. And I'm recording. Good. Second thing I want to mention, okay, I missed last week's episode because I was traveling. Next week, I have to skip yet another episode, or we have to delay The Joy of Coding another week just because I'll be having meetings and that I can't escape from next week. So the week after next is the 100th episode of The Joy of Coding. It's taken us a while to get there. I feel like we've just been crawling slowly, bit by bit, towards the 100th episode, and we're almost there. It'll be on May 17th, so be there, be squared. There's a 100th episode survey where I'm going to be working on some bug. I found a list of bugs that had a high number of votes on Bugzilla. I'm going to work on the bug that people vote for. I've got a bunch of submissions already for votes on what bug to work on. Now, I'm not guaranteeing that I'll end up being able to fix the bug and landing the patch in Firefox, but I will see if I can find some kind of solution to this particular problem. Maybe that'll mean closing the bug because it turns out we can't fix it, or we don't want to fix it and we never will, or writing an extension to do it, or I don't know, finding some kind of alternative, or fixing it. Who knows? Or at least getting the ball rolling there. So that is happening the week after next, 100th episode. It'll be a big celebration. Whee! So there you go, 100th episode coming up. Next thing I want to mention is this whole agenda that we're looking at here with all these links that you might want to click on is actually available to you. If you're on YouTube, it should be in the video description. There should be a description and the agenda link there. Hopefully it's up to date. I'm pretty sure I copied those over. I'll double check that later. Actually, let me check that now. Streams ABKD and the, what is it? What is the copy link? Public link should be ABKD. Yeah, okay. So YouTube's got the right link. I've put it in a comment in the Facebook stream. I've got what is it? The Twitch chat. I'll drop a link in there right now to the agenda. Bam, done. It's in the Twitch chat. For Air Mozilla, it's in the additional links section if you scroll down below. And there you go. Now you have access to all of these links and stuff. I also want to point out that, let's see here. Yeah, a couple of updates. So last week we were working on making tab closing faster. We actually were working on that for a couple of weeks. Hey, guess what? That stuff landed. Things have landed. Tab closing is quite a lot better in the base case or in the simple case. I wrote a blog post about it. Maybe I'll show you that as well. If you go to my blog, let me add a link. I wrote making tabs close faster in multi-process Firefox. I'll put a link to that in the agenda. And there are also these like telemetry dashboards where, I'm not sure if you can see this, but there's this red line that shows the 95th percentile for things like how long it takes to close a tab. And right around here is where we added our patch. This is when the patch was made available in Nightly, and there's this nice fall off here in the graph. The mean went down, the 95th percentile went down. That's quite nice. There's another one here for how long we spend processing before unload in general. That's got a nice steep fall off here. So that's good. Things are good there. We have made an impact. And if you're curious to know how that all works, the blog post will hopefully clear that up. Let me just hit save so that that synchronizes. If you reload the agenda, that should have the link now to my blog post. The other thing I wanted to mention is that the reader mode panel removal that we were doing the other week, that's also landed, that's done. So that's 2 performance bugs that we fixed. Speaking of performance, I've been soliciting people, my viewing population here, to submit performance profiles. That's up here in the agenda. Help make Firefox faster. I haven't sort of done a large scale broadcast of this. I'm still trying to get my ducks in order, but essentially I'm trying to have a second show parallel to the Joy of Coding, where I will examine performance profiles. This is basically the black box recording of what Firefox is doing whenever it's slow, so that we can file bugs or tell people, hey, this is why Firefox is slow and here's what you can do to make it faster, or we can like fix the bug if it's a bug in Firefox. So there are some links here on how to gather a profile and a link to give me your performance profiles. This has not happened yet, my show. This has not happened yet because I've been traveling and having all these meetings, but soon it'll happen. So brace yourself. I know I've been saying soon for a while. It's going to happen. Also, last week I think I mentioned, or the week before last episode, that Sam Foster, had the idea of putting together an episode guide, and I got my first pull request for episode 98, which was the previous episode, and really it just copies the agenda over. But if you want to contribute to the episode guide, this is how, like, I'm very liberal in how I will accept pull requests, so go ahead and add notes. Maybe you want to pull down what I might end up just like taking all of the agendas, for example, and just stashing them in a folder in the sort of Evernote format, and maybe someone out there wants to write a tool or find a tool to convert them all into Markdown. I think that's what Aaron Ramist did here. Aaron Ramist found some way of converting it. Hopefully he didn't do it manually, but at any rate, thank you so much, Aaron. A big thank you to getting the ball rolling here on the episode guide. And that's a thing for you viewers. If you want to add notes, your own notes on things that have happened that you've seen that you thought might be interesting, or maybe some corrections, do send a pull request. That's hosted here. I'll put a link, or I've already got a link in the episode guide, in the agenda. Boom! Click on that. Send pull requests. So, what are we working on today? Today we are going to write tests. We're going to be writing synchronous reflow and synchronous style flush tests. If you're not sure what reflow and style flushes are, I actually have an MDN article about that. So I wrote this with a couple of other folks, and I'm going to put a link to that in the agenda, but it explains what a synchronous style flush is, what a synchronous reflow is, and do give that a read if you're curious. But we're going to be, essentially, those things are we should avoid. That suffice to say, we need to avoid those things. Sorry, I'm just looking for the power adapter. I realized I'm not plugged in this laptop, and I need to plug it in before I run out of power. Oh, I am plugged in, but the adapter itself is not delivering power. Why is that? Come on. Power? There we go. It was plugged in, it was just not delivering power. So we're going to be writing some tests to make sure, like, there's an ongoing effort to find and reduce the number of synchronous reflows and style flushes. In fact, I've written an add-on called Oh No Reflow, which maybe I put a link. Excuse me, I've got a link here on how you can install it to help detect reflows. That's Oh No Reflow. But a bunch of bugs have already been filed from Oh No Reflow. Like, if you look at the way that the reports are generated from the add-on, a lot of bugs for these stacks that cause the reflows, because usually the reflows we want to avoid are ones that are generated in JavaScript. A lot of them already have bugs attached. So we can look at this bug and see what's going on here. And we can see that, hey, this one is currently unassigned, but we have a sense of where the problem is. We actually have 2 different stacks coming in 2 different ways to this rebuild. And once this bug is fixed, it'll be only the first time. So that's interesting. We do a flush the first time. and not subsequent time. So in a way, we've already kind of improved it. And you'll notice that also we're doing these reflows whenever I switch tabs. That's not great. Those are all, I believe, caused by focus, or some of them are caused by focus. Some of them are just caused by native code flushes. I'm not sure if there's much we can do about those, because we're changing the structure of the page. I'm not sure if we can do much, but let's see. What do I want to say? So we've detected a bunch of these things. We want to get rid of them over time because each one of these things can be potentially expensive. And while we're doing that, we also want to write tests to make sure we don't introduce new ones. And we already had a couple of tests. There was one called very simple cases that we were testing, like opening new tabs and opening new windows. And I'm in the midst of kind of consolidating those tests, making them easier, and making it easier to write new tests that are similar so that we can test a bunch of different scenarios, not just tab open and window open, but also tab close, window close, tab switch, tab move, like awesome bar move, menu open, like all sorts of things that we want to make fast because we know users do it a lot. So that's what we're looking at today. I'm not sure how many tests we're going to be able to write, but I'm in the midst of cleaning up some tests right now. You caught me kind of in the middle of things. There's like a Greek term, I think. You caught me, I don't remember, but there's a term like in the middle of the action. You've caught me in the middle of the action. So what I've done is I've cleaned up. Let me, how best to get you caught up with what's going on. I pushed some patches, and maybe we can quickly look at those and see what we're doing, just so that you can get a sense of it. So the first thing I did, let me bump up the font. The first thing we did was we had these two, the tests for tab open and window open in kind of the general test folder, and we want to move tests out of that folder. We never want to add new tests to that folder because that folder has a lot of tests in it. General is really generic. We want to kind of have specialized folders because that makes it easier to sort of chunk up tests and make our tests run faster when we run directories like this instead of having a giant dumping ground like general. So I created a performance folder and I moved the two tests in there. That was what this first patch did. It just moved them. And then I added a utility method inside this head.js file, which is included in each one of the tests, to make it easier to write these reflow tests. It kind of consolidates the logic so that you kind of, I'll show you an example of it being used here. So before we were doing all of this, like, let's see, manual adding a reflow observer and waiting for things. Now we can just say like yield with reflow observer, pass the window that we're going to be observing, the expected reflows, and then a function that is asynchronous that we can like exercise certain things. And then whenever this function exits, the reflow observer is unregistered, and then it will then check to see whether or not there were any reflows that we expected to see that we didn't, or if we saw any that we didn't expect to see and we did, because in either of those two cases we want to like explode and fail the test. So that's what I did, and so I converted the tab open test to use our utility, and I was in the midst of converting the window open one to also use the utility. In fact, it's greatly simplified the test. If you look at the original browser window open reflows.js, this is the current test that's in Central. It's actually quite there's a lot going on in here. We were able to simplify it quite a bit. This is really just the test now, whereas before this whole thing was the test. All of this stuff, I've kind of simplified it, especially thanks to the fact that we're extracting and putting the common logic inside that head.js file, so that's nice. But while doing that, I realized that the head.js file it's being a little too strict. So there's the type of reflows that we want to avoid are the ones that are caused by front-end JavaScript code. and we don't really have the ability to deal with flushes, style and reflow flushes that occur in the native layer. Um, those might be bad, but it's hard for us to tell the difference between the bad ones and the good ones. So, for example, a bad one is like, I don't know, an event is captured in the native layer, and so it causes asynchronous style flush. That's a bad one. A good one is whenever styles have changed, the refresh driver ticks and goes, oh, I need to reflow now because styles have changed, and so I'm in the standard pipeline of um, making pixels go to the screen. That's this part, this layout step. This is the pipeline that gets pixels to the screen. If a reflow happens here, that's what we're writing tests for. If a reflow happens in like sort of the native underlying layer in here or outside here, we can't really detect it or tell the difference between that and this. So the bad case in the native a native reflow is hard for us to detect, so we want to ignore those. And I didn't realize that before, so I kind of had this ability for it to like throw assertion errors whenever native reflows occurred, but I realize now that that will fail intermittently because some of the time the sort of the standard full page, like getting pixels to the screen reflow will occur, and that's just going to happen, and we don't want to write flaky tests. So for now, we're just going to ignore native reflows. That's kind of the summation of that rambling there. Is we're going to ignore the native reflow case, but that means I have to modify our utility method, and I was in the midst of doing that. So let's take a look at what we've got in our change that is not yet committed. So I was messing around with the window open test. I simplified a bunch of things, and that's fine. We're going to ignore that. But here, the change to head, I'm going to remove the documentation I added about native reflows and the handling of native reflows. And so we're going to just commit the head part, but we want to do it when we introduce head. Like we don't want to we actually want to like modify this commit, which has already been pushed. Right now we're on a commit that hasn't been pushed to review yet, where we're cleaning up the window open reflows.js, but we actually want to make this change to head.js in this earlier commit. So we have to do a little bit of mercurial gymnastics. So what I'm going to do is I'm actually going to shelve the change to window open. So we'll start there. We're going to shelve that change. Whoops. Shelve. Oh, I'm in the performance directory right now. So I'm actually going to go to the root directory because that's easier for me to reason about. And now we're going to run that command. Tblot worries that I'm rewriting history. Don't worry. This is Mercurial makes sure that whenever I'm rewriting history, I'm not going to screw other people down the line. Git makes that very easy to screw other people because you can like rebase and rewrite history and then push to your Git repo, and you could use force and then everyone's screwed. With Mercurial, that's very hard to do. Mercurial has a kind of what's called a mutable change set thing. Mercurial, you might enjoy this documentation about change set evolution if you're curious about rewriting history. I'm going to add that to the agenda. Mercurial, change set evolution and rewriting history. There's a link. I'll drop one into the Twitch chat as well because the fellow who brought that up, Tblot, you're in the Twitch chat, so there you go. But we shouldn't be worried about rewriting history because Mercurial makes sure that we're not screwing people. And there's a long explanation about how that works, and it's in that document I just posted. So we're going to rewrite history. We've shelved the change, so we should only have the change to head.js now that's uncommitted. So let's see here. hgdiff. So yeah, here's the change to head.js. It's the only one, so that is fine. We're going to shelve that as well. Shelving is similar to git stash. So now we've got this sort of stack of shelved things, and the one on top is the head.js change, which I have now shelved. So we have a clean working directory now, and I can go to the utility method change set, which is this one. So I'm going to go hg prev. That will move us from here to here. Prev is a command that I get with the change set evolution extension, which is related to the link I put in the agenda and the Twitch chat. I know I might be talking a lot. I'm and like babbling. Hopefully I'm being clear. I'm heavily caffeinated. So I'm going to unshelve the head.js change set, which should apply cleanly, because there shouldn't have been any other changes to head.js in the meantime. So it's going to do the rebase, and it should apply clean, no problem. Rip do 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 do. And done. Come on. Okay, done. So now we should have our HG, our HG should show us our API.js change. That's the one. And let's just double check and make sure we don't have to do this again. We're going to look inside the head.js file. We're going to look for any other references to native, actually. Native stack traces. Here, I'll bring up the font even more. Oh, Sublime hates it when I pump the font. Because then Sublime has to do reflows. So, like, reflow is like having to deal with the size of things changing, and so having to relay out things. And so I suspect that Sublime has to do similar relaying out of things whenever I increase the size. So reflow is a problem in general, in just layout frameworks and stuff. Okay, so I think we're okay here. We're going to commit this, and this is going to rewrite history. I'm going to commit amend, and that's going to create a new commit and obsolete the old one. So I don't want to change the commit message just yet. I'll probably want to do that once I think of who I want to review this patch. But now if we look at the graph of the change sets, we've got the old commit down here. It's obsolete, you can tell, because it's got a little X here. That's the old change set. And this is the new one that we've created. We're on top. We're going to rebase this on top of this, and then this obsolete change set will disappear. It's still there. It's just because Mercurial hates throwing stuff out. But it's still there, but it's hidden. So we're going to rebase our change, and then we can unshelve the other thing that we'd shelved, the change to window open reflows, and then we can commit that. I think we should be safe to commit that, and then we have our two tests, tab open reflows and window open reflows, having been more or less fixed, and then or like rejigged to use our new utility method. So let's look at the graph again. We're going to go up to tip. It'd be great if Mercurial was faster. One of the things that I think is supposed to make Mercurial faster is if I'm running Watchman, and I think Watchman is running. Is Watchman running? If I like ps aux Watchman, ps aux grep Watchman. Yes, it is running. Watchman, help. Watchman. Since? Wrong number of arguments. I'm curious to know how it's doing. Don't trust it with no spawn. Like, how do I find out how it's doing? How do I know if it's being used properly? I don't want to spend too much time on this. I just want to like Waits to root cell down for trigger new. Okay. Docs. We'll install Watchman, cd Watchman, autogen, compile time, configuration, then system preparation. Default per process descriptor limit is Watchman will attempt to raise descriptor limit. Starts to need a message. Just following will raise limits to allow 10 million files. Okay, maybe we'll run these just in case. Max file. Yeah, that sounds fine. I'm sorry to be distracted. I just want to make sure Watchman is running properly. Will cost value persist across reboots. Okay, so let's do that. syscontrol.conf. syscontrol.conf, that's what it was. Okay, and what else did I want to do? I want to commands. I want to see what was being watched. Deprecate real clients app. Adopt the watch project command. Will real path the directory. How do I find out what's being watched? Query. What's query? No. Query. Watch list maybe? Okay. Watchman watch list. So we're watching C record Mozilla Central. Good. So we're watching the right thing. That's fine. So hopefully Mercurial will start speeding up. I hope I am using Watchman correctly. Let me make sure that I've got the Watchman extension installed correctly. .crc. Ooh. Watchman. I think it's going to use it by default. Watchman, Mercurial. And which version of Mercurial do I have? Sorry, I've got like a window off screen because there are some things in my HDRC I don't really want you to see because they are like API keys. Watchman. It was merged into Mercurial. And then FS monitor. I think I have that. Yeah, okay, it's on. It is on. I don't know, off was paranoid. Off will disable self modes. On FS monitor will be disabled. It was the default. And that's paranoid. Okay. So apparently I've got all the things I need. So let's not worry about it anymore. So we blew a couple minutes there just thinking about trying to make Mercurial faster. Where are we at? I'm pretty sure that if I do hgdiff, we haven't unshelved anything, so we're going to unshelve our change to the window open reflow test. Sorry for wasting a little bit of time there. I know your time is precious. So is mine. Okay, so we've unshelved our changes. Ra-da-da-da-do. Let's wait and wait and wait. Okay, we're done here. So now we're going to, I think, commit this change. I think this is all I use git kappa, says tblot. So the problem with using git, or one of the things that's happening is I'm uploading a crash plan. Maybe if I pause this, that might help actually, because crash plan might be improving this. The problem with using Git is that Git would be just as slow, maybe even slower. Mozilla Central, the repository I'm working on, is hundreds of gigabytes large, and Git falls over on repositories that large. I think we are several orders of magnitude larger than the Linux kernel in terms of repository size, and um, Mercurial and Git are both quite fast whenever they deal with small repositories. When you get to really large repositories, Mercurial is actually faster. So if I was using Git right now, I'm pretty sure it'd be just as slow, or maybe even slower doing things like rebasing. Um, that is my current understanding. So yeah, the changes that we made here to window open reflows, I'm happy with. So I'm going to create a new patch. I'm going to say, oh, whoops, didn't mean open calculator. I'm going to say convert. What was the other format I used for this? Clean up browser window open reflows.js. That was the name of the file, right? Window open reflows. Window open. Yeah. And remove items from the whitelist. Tblot asked, does reading repository objects actually get slower as the repository gets bigger? I think the graph search that needs to occur just gets slower. Mercurial Git performance comparison. Zork. The reason I want to talk about thoughts on Mercurial and Git version performance. Greg Zork has a great blog about Mercurial, and let me see here. I wish I could search it. Is there a way I can search performance? Search it on cloning improvements. Okay, numerous performance improvements. Performance versus Git. Git is running rings. The fact that it's written in Python, that wasn't the case at all. Faster Mercurial, there were reports Facebook has made Mercurial faster. Scaling HG, this is what I was thinking of. Yeah, Facebook makes Mercurial faster than Git. Large. Prohibitively large. There's something here about large repositories. The entire code is a single large repository. So this article you may find that interesting. Something like that. Outperform Git on pull clone, working directory status calculation by a factor of 5. Yeah. Okay. Anyways, enough distraction. Let's move on. So we've committed our change. So now let's run our tests. Base content test performance. Let's run window open reflows. That's the one that we were just dealing with. That passed just fine. Then we're going to do tab open reflows, and then I think we should push this to try to see if it falls over or there are intermittent failures with it. We're going to re-trigger the test a lot, I think. This one failed because I failed to remove a native reflow marker from browser tab open reflows. So I'm going to go back our revision, and we're going to clean up this commit. We're going to remove the native code reflow line. So that's from tab open reflows. Going to get rid of this native reflow. Commit, amend, and then we're actually going to use HG evolve. I rebased manually before to kind of make it easier to see what I was doing, but evolve actually does that for me automatically. So it's going to figure out, oh, you've got an obsolete change set. I'll just take the thing that's on it, and we're going to put it on top of what you ended up um, committing instead, like the mutation. So that is it figuring out how to do that, and it is almost done. Done. Okay, so we should be on the tip. Great, so let's run our tests again. Tab open reflows, and then we're going to push it to try, and then let's write some new ones. We're going to write some new tests. Great, that one passes. So let's push this to try and see what explodes. We're going to do some artifact builds. We're going to do some Linux, Windows, and we're going to do both debug and opt, and we're going to run all the BC tests because I don't actually know where the reflow tests are, where the performance tests are. And let's see. We're going to retrigger all of them about, well, I won't retrigger any of them because, oh, you know what I can do actually is I think I can run an entire, just a subdirectory. If I use mock try, and then I do something like, I've done this before, mock try b do p linux 64 mac os x 64 and then win32, and then I say t none, and then I can pass it a directory, base content test performance. I think I can do this. Creating a temporary commit. Oh, hang on, note, and then I want to say artifact. I also want to do an artifact build. So let it think about that for a second. Boom. Okay, so we pushed to try, and I don't even know what try syntax it came up with. Let's see if we can read the try syntax it came up with. Oh, it's going to take a while for the push log to be updated. There's like a message queue thing. This will be updated in a couple minutes. But in the meantime, let's go about writing our new test, or a new test. So what do we want to test next? Well, we've done tab open, we've done window open. We should do tab close as well. One thing we could do is well, yeah, let's write a new test file here. So I'm going to say new file. I'm going to say we're going to add it to the list tab open reflows, browser, tab close reflows, and I'm going to put that actually in alphabetical order, tab close reflows, and I've got my new file. I'm going to call this tab browser tab close reflows. And it's going to be very similar to tab open reflows. I don't know what the expected reflows are, so I'm actually going to take these out. I'm going to get rid of this as well. All of this stuff was only interesting for tab open. No, unwrapped when closing new tabs. Okay, so let's see. We're going to open a new tab outside of our observer, so we have a new tab to work with. Let tab equal yield browser test utils. Open new foreground tab. I think open new foreground tab can be pointed at like some web page. It'll open at about blank, and we can wait for it to load. Opening. Okay, we're just going to open a new foreground tab at about blank. And then we're going to wait until we've closed the tab and the switch is done. Yeah. So we're going to say tab G browser remove tab. I think it's that. And nothing like that is required. So removing the tab, right? Remove the tab, wait until the switch is done. And that should do it. That's our test. So we're going to probably see some unexpected reflows. That's okay. We might actually have to build. So let's do that. Okay, so now let's run our new test. Base content test performance. We're going to say browser tab close reflows. Let's see what happens now. Oh, we're just sitting here. Why are we? What are we waiting for? Transition end. Oh, when we close a tab, we don't. Is this what we're waiting for? Transition end. G browser selected. Oh, we should wait for it on the tab. That's what we should wait for it on. So let's run that again. Not the selected tab, because a switch occurs. Still waiting. What are we waiting for? Dump. Tab removed. Waiting for transition end. Dump. Transition end done. Trying to remember how this tab close animation works. Pretty sure there should be a transition end. Oh, we're skipping the animation. That's why. Let's see. So we need to not skip the animation. Remove tab. We should make sure that we're animating. tabs animate. I think just bypassing animate true, like that. Okay, so what are our unexpected interruptible reflows? So this is what we're going to add to our list of what we've currently got as our reflows. Not great that they exist, but if they exist, it's better to know. And then we just have to make sure that we don't add new ones. So what's a good, let's see. And we're going to get rid of all of these like line numbers. Let's see if we can do some regex magic here. Replace, find, there's like a regex thing down here. You probably can't see that. Whole word, regular expression. So if we see that and then 0 to 9, any one of those, and then that again, and then 0 to 9, and then a quote, just do the quote. And we're going to do it in just the selection here. Let's see if it works. Nope. I wonder if these oh, that's why. Outside. Outside. Eh? There we go. Okay. So we got rid of all the line numbers, and now we're gonna, what's the other one? We're gonna do another one, I think right here. Fill trailing gap on the transition end. Replace. Fine. Replace. There we go. And I think we can get rid of these dump statements now. And this should pass. Good. Okay. Now, how about if we disable E10S? Is there anything? Aha, there's something different with non-E10S. Expected. Looks like the stack's slightly different. Update current browser, adjust after. So what we can do actually is we can do that, because in the end, this is where the reflow is. So we're going to get rid of that, and then what's, yeah. So this should pass now. Oh, T-Blot, you were right. The plus sign is what was the problem. T-Blot is in the Twitch chat, is reminding me that the plus sign inside my regex is the problem. That is true. We figured it out. We're okay. Thank you. Sorry, there's a little bit of a delay, which is unfortunate because sometimes there's some really good ideas that come out of Twitch, and it's like 30 seconds or a minute past. Like I've moved on or something, and I have to kind of go back. Okay, so we have our test passing now. That's good. Let's see. Is there anything else we want to do here? I think that's it. So we've got tab closed now. That's good. Let's see how our test is doing. We pushed to try, and it's cooking. They're cooking right now, so hopefully this doesn't take too long. And we can retrigger them a bunch to see if there are any like intermittence. In the meantime, we can add this file. Content test performance browser tab close reflows. And then we're gonna, what was our bug number? Whoops, bug. We're gonna say, trying to remember. Oh yeah, add reflow tests, regression tests for tab closing. Now there are a couple of other cases we want to consider here. So we've got tab closing. What have we got? We got tab opening, window opening. Those are done. We've got tab closing now. We've got a couple other we want to deal with. Window closing. Then there's like tab opening with overflow, with overflowed tab strip. There's tab opening squeeze. That's whenever we open a tab, like, hang on, if we have a bunch of tabs, notice how these tabs like kind of scroll and squeeze, they get smaller. We probably want to test that case as well. We also want to test tab closing overflowed, tab closing, oh, and tab opening squeeze to, or enter overflow. Tab closing with overflow tab strip, tab closing, exiting overflow, tab closing squeeze. Okay, what else? Then we want to add tests for well, we can take a look at some of the reflows we've already removed. Hey, we got some orange. What do we got? Unexpected interruptible reflow. That's what we wanted to see. Oh, and this is in the non-ETNS case in new tab. Unused. So this one was unused. This one was also unused. Delayed startup. Interesting. Delayed startup. And this test timed out. The test timed out. Why would the test have timed out? We'll have to look into that later. But some of our tests might be a little flaky. So, to do. Find out why test is orange on Linux 32. It's probably going to be orange on Linux 64 as well. Yeah. 64. Oh, sorry, it's Linux 64. They're both 64. 64. That one says it's it's not grid, it's something else. And ETNS, this one says an unused unexpected reflow on Linux. And this one, so the test times out here and here. And then down here, and we've got a couple of unused ones, unused expected reflows. That's interesting. We've also got some ESLint failures. Infix operator should be spaced. So we've got some linting that we need to do. Yeah, wow. Yeah, we got some linting to do. I'm surprised that it allowed me to commit. We've got some linting to do. Okay, so what do we want to do? What's the next step? So we've got a couple of choices. We can try and figure out why our test is failing here. Um, that might be a good thing to do. And we can also fix up our linting. I'd like to do that at the end. That's something that like um, I don't usually worry about until the end, but you know, maybe I should just do it. Maybe I should just do it. Let's just do it. Okay, so here we're gonna lint the head.js file, mock ESLint, make sure I've got the latest stuff. NVM use NVM. What am I using? NVM use. I think I want 6.9.1 actually. And let's make sure we've got the right ESLint stuff. Okay, now we'll run ESLint in browser-based content test performance head.js. Okay, so we've got an unused variable. I forgot to get rid of it, so let's deal with that. Where is it? Line 64. This thing's never used. Good call, ESLint, because I use path with line numbers. Okay, so let's commit that. Meanwhile, we can do two things at once. I've got my sort of beefy Linux box that I could load our patches on to see if I can reproduce the problem over there for the timeouts that we're seeing. So we're going to commit this. So beefy Linux box. How do I? Beast mode is what I call it. So Mozilla Central. I'm going to pull in these changes. This one here. HG pull R this. I think I can do this. Try. Yeah, there we go. Update to tip, and then let's see if we can reproduce the issue. You probably want to be able to read stuff, don't you? Okay. So over here, we're in beast mode. I'll build real quick, do a fast build, wait for that to finish. And in the meantime, while we're waiting for beast mode to finish, I will shrink this window so that it's a little more manageable and I can see beast mode in the background. And I'm going to continue to fix up the ESLint stuff. So the next step is to fix up tab open reflows. We're going to rebase that one, then we can commit amend it. What's also interesting is that ESLint doesn't appear to be working on commit for me. That's a thing that I used to have working. I wonder why that's broken now. Let me see if I can find out. Again, I have to look inside my HGRC, so I'm going to do that privately. Moz ESLint is activated. So like if I were to commit this one up the top, I would expect if Moz ESLint was working, I would expect it to so I'm going to commit amend. It should spit out an ESLint error. Maybe it's been spitting out errors at me and I'm just ignoring them. That's possible. Nothing changed. Um, like, I'll put a period at the end of the commit message, for example. Why isn't why isn't ESLint complaining? Are there problems in that file? There should be. Browser, base, content, test, performance. Was it browser? Um, what was it? Tab open reflows. Yeah, there's a problem in here. Infix operators must be spaced. That's line 53. Let's tab open reflows. Line 53. Infix operators must be... Ah, I'm missing a space there. It's worried about that. Okay, so commit, amend. So why isn't Moz ESLint working? Maybe I need to, like, update it. Okay, next we're going to rebase the window open reflows test. And one of the things I'm going to do from here on forward, actually, is I'm going to, until I can figure out why ESLint isn't working on commit for me, I'm going to manually run ESLint every time I commit. Why isn't ESLint working? What is it? ESLint validate.py. Is there like a gecko dev in tools, mercurial, and gecko dev? So it's actually in the tree now. In tools. Yeah, and that's what I'm pointed at. Is lintable. Lintable is anything that's here. Path ESLint hook. I wonder what's going on. Is this even being entered? Hooks commit ESLint. All right. So let's run. Wait, I think I actually have to update to the tip. I'm pretty sure I'm on. Yeah, I have to update to tip. Oh, and beast mode's done our build. That did not take long, thankfully. So let's run our test. Now, in order to do this, I think I actually have to install VNC server because I need a display for this thing. Long password. VNC. VNC4 server. Okay, and what's a good password? What? What? Password too long. Jeez. All right. So we started up a VNC server at 1, and so now I can do display equals I think 1, like that. And I think I can do mock, moki test, browser base, content test, performance. I should be able to do tab. What was the one that was failing? It was tab open reflows, and window open reflows also failed. But let's figure out the timeout first with tab open reflows. And that's E10S disabled. I spelled moki test wrong, and thankfully Mock figured it out. Thanks, Mock. So it didn't time out. That's interesting. But I did get, and it passed. So, what if I run until failure? I'll just have it repeat a bunch. And in the meantime, we'll continue our quest to clean up our tree. Browser, window open, reflows. I should probably just have ESLint running in my editor at all times. I think there's a way of doing that. I don't remember what it is. I'll look it up after the episode. Last transaction ID, never used. And that was on line 54. This thing, never used. That is correct. Actually, I'm interested now. Window, was it Sublime, ESLint, Mozilla? I think someone. Sublime Text 3, yeah, install Sublime Linter. ESLint, local. Okay. So we need Sublime Text 3 and Sublime Linter. Let's do that. Install package Sublime Linter. And then install the specific ESLint plugin. The installation instruction provide details about how to install Node npm ESLint, which are required. No, so that the errors are shown for source files are ignored. Preferences, package settings, preferences. Whoa, hello. Hello, Sublime Linter. So preferences, package settings, Sublime Linter settings default. Oh, I need settings user. So close. Preferences, package settings, Sublime Linter settings user. And then I'm going to say add args no ignore. So what's the syntax here? Settings, Sublime Linter default. Args. To the ESLint linter object. There is no linter object. Maybe this is not what I need to do just yet. I have to install maybe the specific ESLint plugin, which is already installed because I use it whenever I'm committing. At the local ESLint installation, okay, so like if I do mock ESLint setup, here, paths, and paths on OS X. Okay. Open the Mozilla project. Trigger the linter via the contextual menu. Shortcut. So let's try and cause a linting error. Have I? So mock ESLint browser-based content test performance. Let's just lint this whole directory. So inside window open reflows. Sublime linter, lint mode, background. And I'm not seeing any linting problems. Where would it be? On line 52. I would expect there to be this thing complaining about it's not being used. So is it because I skipped the step in here? Install the specific ESLint plugin. Maybe I just need to do that, which is weird, but okay. npm install g ESLint. Oh, hold on. Install package when the plugin list. Install package. See, Sublime Linter contrib ESLint. Okay, so that's maybe what I wanted to do. Install package Sublime Linter contrib ESLint. Installing. Done. And I have to follow the instructions here, apparently. Jeez. This is so complicated. Selection, yes. Node, ESLint, yeah. Plugin installation. So, like, is it working now? Like, Sublime Linter. Lint this view. Lint it. Lint. Like, Sublime Linter. Lint mode. I thought I saw an error down here about linting. It's remote error, one error, line 55. So what? It's saying there's an error. It's not really displaying. Oh, whoa. ESLint crashed. Oh, lovely. This is great. Browser window and browse. That's great. So happy with ESLint. I'm so glad I decided to do this. Well, I'll configure it later. Anywho, where were we? Yeah, we want to get rid of this line here. That's easy. Done. We're gonna now lint, and it should be fine. We're gonna commit. Holy smokes, I did not expect to get caught up in linting land today. Ooh, this one failed because of this. We expected a reflow and we didn't get one. So one of our reflows happens kind of non-deterministically, or our test has some leakage or something where like a thing that we expect to happen sometimes doesn't. New tab on transition end. How many times did it run? Like only the once? Alright. Well, anyway. Now where are we? I have this last thing. We're going to rebase that on top. Um, beast mode passed in that case. So run until failure is where the test fell over. I wonder if maybe I need to wait for the tab switched. If it's running too fast, maybe. It might also be a problem of one test influencing another. Unused unexpected reflow that time. Yeah. So get scroll position. This doesn't always happen. That's a problem. We need to figure that one out because this test, I don't want to fail intermittently. So we better figure that out. Either make it so that if it's just unavoidably non-deterministic, then we need to somehow update head.js to deal with things that may or may not occur, which I really don't want to do. I want it to be deterministic. I don't want there to be sometimes reflows and sometimes no reflows. Let's see. So get scroll position happens on the transition end. Handle new tab. Let's add some logging and see if we can figure out when how this reflow is not occurring. So that would be inside. Let's do it inside tab browser actually. Content tab browser.xml. In transition end, we'll do handle new tab and fill trailing gap. Handle new tab here. And we're going to add some logging. I'm going to say dump M Conley bailing out at 1. I'm just going to use checkpoint numbers. I know this is kind of silly. Dump M Conley calling fill trailing gap now. And then dump M Conley not calling fill trailing gap due to 2. Else dump M Conley not calling fill trailing gap due to 3. These numbers just tell me where I expect where things are occurring. So I'm also going to have a message here. Handle new tab entered. And then there's the handle or fill trailing gap itself. Here where scroll position, scroll by pixels. Dump I'm calling scroll by pixels else dump I'm not calling scroll by pixels. So this is all an attempt to figure out why we might be skipping that reflow. So let's run that again, see how it fails. Over here, we're done our linting, so now if we run eslint performance, this directory should now pass, which will be nice. That's great. Now what do we want to do? Well, while we're figuring out this timeout, well, right now we kind of got distracted from the timeout because we can't reproduce the timeout, but we're dealing with an unexpected reflow, or an unused unexpected reflow. Handle event, unused unexpected reflow. Handle event. This one, same thing. Oh, this one is select. So window. What I want to do actually, so this one, oh, good. We've got our failure here, so maybe we can look back and see what happened. Oh, the test timed out. Hey, great. Unfortunately, I didn't see why. um, the test timed out, though. That's good. Not calling scroll by pixels. So what happened was we start the test. We got this expected reflow. We got this expected reflow. Calling fill trailing gap. Yeah, we got that expected reflow. And then we must not have called one of our test performance browser tab open reflows. One of these two things that we wait for must not have happened. Either the transition end didn't occur. Transition end didn't occur. Or the tab switch done event didn't fire. So let's see, which one would it be? Waiting for transition end event. Dump, waiting for switch, tab switch done event. So let's run that again. Meanwhile, back at the ranch, while that's happening, so we're sorting those out right now. On Windows, what do we have? We have an unused unexpected reflow, or an unused expected reflow. I got a feeling that's not a good thing, unless this reflow just never happens because on Windows, what is it? In browser tabs and title bar. In window open reflows, how does this reflow work? Window open reflows. Here, this one. Cause a reflow in OS X and Windows trying to do calculations and the layout info is already dirty. This doesn't seem to happen before Moz after Paint on Linux. Interestingly, it passes over here on tier 2. So that one may or may not occur. Handle event. Update appearance. So what event is that? Handle event. Unused. Oh, we didn't get the reflow that we expected. Handle event, which we'll call update appearance. So handle event inside tab browser calls update appearance. And so how does that work? Tab browser. This one on resize? Resize event. So a resize event also sometimes occurs? Interesting. I wonder if we need to make sure that we wait for that event. Because right now we're just waiting for a paint, or delayed startup, which is triggered off of paint. But maybe we also need to wait for resize. Okay, so it's a thing to think about. What's happened over here? Test timed out because why? Why? Waiting for transition end event. The transition, oh, waiting for tab switch done event. The tab switch done event never showed up. That's why. So why would the tab switch done event not show up? For the tab switch done event. And this is in browser tab open reflows. Why would the tab switch done event not show up? We open a tab. I guess it wouldn't happen if we weren't switching to the tab for some reason. Did it take a screenshot? That'd be nice. I think there's a way to tell Moki test to take a screenshot on failure. Screenshot on fail. Screenshot on fail, and then it wants a Moz upload directory. Right? Screenshot. Moz upload dir. Moz upload dir equals projects. I'll just put it there. Okay, so we'll run that again. So one thing I'm curious about over here is if a resize event is expected when we open a window, because that would explain these ones not getting the event that we want. So let's see if one shows up. I mean, on Darwin we get one certainly. So like what we could do is say like win let resize event equal browser test utils wait for event resize win resize, and then let delayed startup equal that, and then we'll just like await both of them. Or we could actually do await promise all resize event delayed startup. Actually, maybe this is better, because in the future, if we're dealing with like things that are sometimes not happening, this might be easier to debug. So let's see if that actually just passes. Moki test browser based content test performance browser window open reflows. This one failed due to an unexpected reflow, or an unused expected reflow. And in that case, oh, and that passed. So we do get a resize event. That's handy. That might fix our Windows case. I'm guessing, yeah, that screenshot's probably not going to be super useful. Let's get rid of it. Mozilla test fail, because that is a timeout, or like that's in the event that we didn't see a reflow that we expected. So the tab would have been closed. I think the screenshot's useless. I want to see the screenshot whenever the test time's out. What state is it in? So let's do a to-do here. Actually, we can probably modify browser window open reflows. I'm going to shelve this, and I'm going to put it over here. We'll push it. Aha! And is this timing out? Quick, while we're waiting, beast mode. Um, Test timed out, and it was just sitting there. Hmm. What does that mean? For tab switch done event. I saw it attempt to switch back. Maybe that's because the tab switch doesn't complete. Oh, I think I know why. Tab open reflows. We need to wait for the tab switch to complete. Then when we remove the tab, we also need to wait for the tab switch to complete at the end of the test. So let's make those changes. I'll actually go back one as well to tab open reflows. So here, tab open reflows. Yeah, here we're removing a tab. We need to wait for the tab switch, the other tab switch done. Yield switch done. Okay, we'll end that. Should be good, I think. Yep. Okay, so we're going to commit that. Then we're going to unshelve the other fix that we had. We'll run the directory locally, and then we're going to push it to try again. And then I think I'm going to end the episode and cap it right there. Or do I want to... Actually, before I cap it, I'll push it to try, I'll pull it down from try onto beast mode and try and do the repeat run until failure thing again and see if there's still failures locally. Okay. Rebased, so now I'm going to unshelve my resize change thing. And I wonder if that's actually going to fix this difference. Like Like, I wonder if this is going to end up failing because we end up having the resize event show up on Linux. Then we can remove this sort of like OS specific stuff in here, which might be good. Okie dokie, where are we at? Okay, so yes, lint it. I believe I'm on the change. Yep. And I'll commit amend. Then I'm gonna push to try, and I'm also going to. Well, first I'll run them locally on this OS X machine. That's maybe a good first step. R dest tip. Scooba-dooba-dooba. Playing music. Maybe I'll play a sound while we're waiting.
Oh, yeah.
Oh, yeah.
Hi-oh!
Okay. Okay, that took a while. Sorry about that. Okay, so let's try running these. Mock, monkey test, browser-based content, test performance. We'll just run the whole enchilada locally. Then we'll run it without etns locally, and then we're gonna send it to try. And while it's baking on try, we'll also pull down onto beast mode so we can test it there. Good. Okay, passed locally. That's nice. So we're gonna push to try again. This try syntax looks good to me. Then we're going to, what did I have committed on beast mode, or changed on beast mode? Just like some debug logging and stuff. I'm gonna shelve that for now. Ugh. I have to add the shelve extension. One sec. Okay. The reason I did that off screen again is because I've got like API keys in my HGRC and stuff. Okay, so we're going to, I shelved it already, right? Yeah, okay, so now I'm going to prune these changes. Don't need them anymore. I'm going to pull these ones down. Wait, did I get prune? I guess I'll strip them. Strip. Gotta enable strip. Girl. Okay, strip. And now I've got this change set here that I'm going to pull down from try. Pull R from try. Update to tip. Build faster, I think, should be enough. Let it reticulate splines for a little bit. And then let's run our test. Sure. Ah, another unexpected fail. We expected... Oh, okay, well that's the other mystery. We solved the mystery... We may have solved the mystery of the timeout. The transition end one we didn't solve. Let's see if we can solve it. I'm going to unshelve the logging I added. And let's run again. I don't think I needed mock build faster for that. I think we're using like symlinks and stuff. Shoot, maybe... Well, let's see. Yeah, not calling... Okay, good. Okay, we got our test unexpected fail. That's good. Waiting for tab switch done event. Waiting for transition end event. Not calling scroll by pixels. So that's where we expected to, but we didn't. And the reason we didn't is why. What is it inside fill trailing gap? Is that what it's called? Vim browser based content tab browser. Not calling scroll by pixels. So tab strip scroll position and tab strip scroll client size is greater than tab strip scroll size. Stay completely scrolled to the right side. Why would this not be true? Dump tab strip scroll position. And we'll use template strings. That'll be nice. Scroll client size. Tab strip dot scroll size. Actually, we probably want to log both of those in both cases. All right, let's run it again. How's our try build doing? Hopefully less timeouts. Oh, it's getting its act together with the artifact builds. Okay, so unexpected fail. Tab scroll position was 0, 921, 921. So scroll client size was 921. And so there was no difference, whereas scroll position, whenever it passes, has this, maybe we should just get it to pass once so that I can see what it looks like. Like, what do the numbers look like when it passes? Still cooking. Oh, shoot. Yeah, shouldn't have gotten rid of that display thing. Okay, it passed here. And so when we got an expected waiting for transition and calling filling trap fill trailing gap now. Fill trailing gap calls get scroll position. Oh, it's the call to scroll position that does it. This call tab strip scroll position. Sometimes scroll position doesn't cause a reflow. Scroll position. So scroll position so the whole um, the fact that we don't call it sometimes doesn't matter. It's here, right here, which will be executed no matter what. So this is what we need to look at. So this is all not useful. So we're going to get rid of that stuff. We need to look inside the actual stack. I probably should have done this before. We're going to look inside scroll boxes, get scroll position. Scroll box, toolkit, content widgets, scroll box, scroll position, getter, scroll box, scroll top. What is this scroll box? Is this scroll box thing the actual scroll box? And scroll top may or may not cause a reflow. Why would that be? Scroll top. Get scroll top. Element scroll top. Why would we sometimes flush and sometimes not? I guess I need to understand why that might call a reflow. Do we have a bug on that scroll position? It's set at get scroll position. Yeah, here. Here's the stack. The sync reflow is when you're using the scroll top and scroll left getters. How does scroll disabled state may be changed? Well, I don't think I'm going to be able to solve this mystery in the short term. I'm going to try figuring out for the rest of the day, but I don't want to waste your time. So I'm going to call the episode right here. We got one test written. We got a couple cleaned up. And let's see, what is Try saying? Try is baking some other tests. I'll put a link to here in the agenda in case you want to follow along. Or I'll put it in the notes for this this bug itself, which is linked to inside the agenda. So you can follow along there. Hey, thanks so much for watching The Joy of Coding. Episode 99. We're one episode away from episode 100. We're so close. Just a reminder that, if you want to fill out this 100th episode survey, that'd be great. Or if you just want to rate this episode, let me know what you thought of this episode. I value the feedback. I read all the feedback. Do let me know what you thought. I was asked, is this even the real streamer? Yes, I'm a real streamer. Hello. Someone in the Twitch chat wants to know if I'm the real person. Thank you so much for watching episode 99. Let me know what you thought. A link to rating the episode, I'm going to put that in the Twitch chat as well. There's also a link to rate the episode. What else do I want to say? Again, I'm not doing a stream next week. I am away, or I'm going to be in meetings. And the week after that is episode 100. Which is, I'm really excited about that. I'm going to be working on the bug of your choice. Do fill out the survey, the 100 episode survey. There's a link to the to it in the agenda. I'll put again a link to that in the 100 episode survey. I'm going to put a link to that in the Twitch chat as well. But it's also linked to inside the agenda, which is all over the place, wherever you're watching this. Thank you so much. I'm sorry I won't be around next week. There is a subreddit called Watch People Code that has some great streams on it. If you want to watch some stuff from other people, or you could watch some of my previous episodes, that's cool too. Up to you. I hope you have a great week next week, and I will see you the week after for episode 100. So that's it. Take care. Bye-bye. Hold on a second. Let me just switch to the splash. Take care. Bye-bye. Have a great week. See you soon.
The joy of coding.
See ya.